you about games engines. Just before that, I'm just going to tell you some of the safety procedures that are in place here. If you have a look around behind you, everybody look back, you will see two doors. Okay. If anything should happen, most unlikely you will be asked to go out very orderly and very quietly out through the doors. No rushing or knocking over chairs or anything like that. But I'm sure that won't happen. But it's important for you to know where the exits are going to be. If you're upstairs, just have a look around behind you and find out the doors that are available for you to go out. Once again, in a very orderly way if you are asked to do so. Okay? Right, now we'll pass over. I'm going to introduce Dr. Brian Duggan. Dr. Duggan has been teaching all of our students to develop games over the last several years. So today he's going to share his knowledge with you and introduce you into the whole area of games development and how it happens. And also, one of our students is going to show you a game that he has helped to develop. So, without any further ado, I will pass over to Brian, and I hope you enjoy your day.
Can you hear me okay? Yeah. Can you guys hear me up in the balcony? Yeah. Good. Right. So, thanks Patricia. My name is Brian Duggan, and yeah, today's talk is called Inside the 3D Games Engine. So I'll just tell you a little bit about myself first of all. I've been a lecturer in the DIT School of Computing for the last 10 years or so. I also was a student here. I started here actually a long time ago, probably before most of you were even thought about it, back in 1990. And as an undergraduate here, we did loads of stuff. We did programming, databases, and artificial intelligence. But I always thought if I had the opportunity to come back here and teach, that I would teach games, because I really enjoyed playing computer games. The first game that I ever played that really kind of captured my imagination was a game called Elite. And Elite was really the first attempt to make a real-time 3D game. And the thing about Elite was, in this game Elite, you basically played a guy called Commander Jameson, and he flew around in a spaceship called the Cobra Mark II. And at that time I used to watch a lot of Star Trek. And I was really intrigued by the idea that, you could have this little virtual world, and you could actually have the opportunity to fly a spaceship and to have a career, as a captain of a spaceship. I just thought that was really exciting. And this is what really got me interested in computer games in the very early days. So this is what the talk is going to be all about. The first part of this talk is what is a games engine. So this is all looking at the technology, and also looking at the history of games engines and the history of 3D games. I've got loads of cool videos of early 3D graphics and the whole history of games. We'll pick a selection of them to have a look at. The second part of the talk, I'm going to look at the actual technology. And if we have time, and if we don't spend too long on the videos, I'm going to do an actual demo of some coding in a programming language called C# to basically show you how part of a game engine is actually made. And we'll talk a little bit about maths and physics as well, because maths and physics really, we all enjoy playing computer games, but every computer game is a computer program. And in order to develop a computer program, it requires a very deep knowledge of certain types of maths and physics, and algorithms and logic and all of that. And the third part of this talk, I'm going to ask my student, Thomas Beaton. So Thomas is a student on the BSc Computer Science course here, and he is going to give you an example of a piece of technology that he's working on, which makes use of the Unreal game engine. How many people here have an Xbox? Alrighty. How many people here have a PS3? How many people have both an Xbox and a PS3? How many people own a Wii? How many people own a Nintendo DS? Okay, that's interesting. So I guess everybody here has played a 3D game. Has everyone played a 3D game? What's your favorite games? 2, or Dishonored, or any 3D game, even FIFA, is a result of many, many years of development. And it's a whole load of different pieces of software that come together. So first of all games, there's sound, right? So there's what's called an audio engine as part of the 3D games engine. There's a networking component. And in fact, if you've ever played Black Ops 2, you might be interested to learn that the networking component was developed by an Irish company. Did you know that? They're a company called Demonware, and they were eventually bought by Activision. So there's Irish people basically developed that component of the game Black Ops, and in fact all of the Call of Duty games. There's artificial intelligence. So this is one of the things that really fascinated me when I started playing games, first of all. You know, the idea that you can have artificial life inside a computer, and you can interact with, you know, these simulated characters. There's typically a scripting engine. So what this is all about is the actual technology to make the game is there and it's standard, but then it's customized. So you take the engine and you can make different games by using the same technology. There's usually a graphics component. So that's what I'm going to spend a bit of time talking about today, the actual graphics. And there's physics, alright? So most games now try and simulate the real world. And here's another interesting fact. If you look at the back of most games that you buy down in Extravision or in the game shop, you'll see a logo. And the logo is the Havoc logo. Has anyone ever noticed that? Yeah. So you'll notice on the vast majority of games that you buy, Havoc are another Irish company. And they develop the physics engines for most commercial games that you buy. So all of this comes together into a game engine, right? Another way of thinking of a game engine that I quite like is to think of a game engine as the magician's toolbox. Alright, so this is the thing that the magician uses. And if you think about it, when people make these games, they're actually creating artificial worlds, they're creating artificial life forms, they're creating this simulated environment in which you can interact. It's rather like a magician, or rather like somebody just going, okay, make me a wall over there, make me a tank, make me a person, make me a fleet, make me an adventure that I can participate in. So this is the aspect of Games Engines programming that really fascinates me. It's the idea that you can actually, you know, wave your magic wand and you can create something out of nothing. Isn't that interesting? That's what I think is really interesting about it. So some games engines that you might have heard of. Has anyone heard of the Source engine? Can anyone tell me a game that's made using the Source engine? Yeah? Team Fortress 2. Okay? Excellent. Great. So, the Source engine is made by a company called Valve. Alright? The Source engine is used to make a very famous game called Half-Life 2, which we're going to take a look at as well. What about the Unreal Engine? What games use the Unreal Engine? What's that? Infinity Blade. Okay, so I haven't played that one. Alright, if you've ever played a game, who's played the game Dishonored? Have you played it? So that makes use of the Unreal Engine. And Thomas's game is using the Unreal Engine as well. CryEngine 3. What game uses CryEngine 3? What's that? Crysis. So Crysis uses CryEngine. And Unity is another very famous game engine used particularly in a lot of mobile games, right? So if you think of a game like Dishonored, right? How many years would you say it takes to make? About 5 years it takes to make. And you know, it's not just one person that makes a game like Dishonored. It's typically a team of hundreds, in some cases even thousands of people contribute to a huge big game like that. It's rather like a movie, you know. And these games cost hundreds of millions of dollars to make now. So, you know, you could be a great programmer, and that could be your contribution to the game, but also to make something like Dishonored takes musicians, artists, modelers, so somebody to actually make all the 3D characters and the worlds that you interact with. To design the levels, there are writers, or people who've done English degrees, write all the stories and the dialogue. There are actors who actually record all of the motions for the characters and also record all the recorded audio, and loads of programmers. The programmer is the thing that we do here in the School of Computing. So I'm going to talk to you a little bit about the history of games. So have you all played this? I doubt it. This is a game from an old console called the Atari 2600, right? This console came out in the late 1970s. And when computer games started to be developed, first of all, there was no reuse. Basically, every game was developed from scratch. Right? The idea with a game engine is that you have a suite of tools, all that stuff I previously talked about, that you could reuse to make lots of different games. But originally all games were basically made from scratch, alright? And so what I did for this little section of the talk was I picked a load of what I consider seminal games. These are really fundamental steps forward in the evolution of 3D computer games. And we'll take a look at some of them, right? So, the first little video I want to show you, let's take a look at this one here. Yeah, here we go. So I've got two small videos here, right? Now I'm just going to look at a couple of minutes of each one. So the point of these really early videos, these aren't even games, right? This is before computers had the capability to render things in real time. So in order to render any of these things, well, let's take a look at them first, right? So this is an example from the late 1960s. So look at that. Does anybody recognize that? What is it? Starship Enterprise, right? So you know all computer programmers love Star Trek. So even back in the 1960s, you know, people were interested in making 3D models of Star Trek. So the interesting thing is the guys that developed this software are really pioneers, and the algorithms that they developed and the mathematics that they discovered is actually still used today, right? Let's take a look at this video from 1974 from the University of Utah. It's kind of freaky. The interesting thing about this was these are not rendered in real time, so somebody would have written the software, ran it on a computer, and come back a few days later, and you would have been able to see these outputs. But look at this. This is nearly 40 years ago. People were able to do this with computers. Like I say, computers weren't powerful enough to render things in real time. So in other words, you couldn't interact with those. You basically had to write the program, go away for a few days, come back, and you could get the output of the graphics. In the 1980s then, it became possible to do some types of 3D graphics in real time. And the first real 3D graphics game was a game called Elite. So I'm going to show you a little screenshot from this, and what you'll notice about this is that it uses what are called wireframe graphics. So have a look at this and see what you think, right? I'll scroll forward a little bit. Here we go. This is the loading screen from Elite. Actually, I'll scroll forward a little bit. So it's 3D. Many hundreds of hours I spent playing this game. Forward. The whole idea with this game is that you're in a spaceship called the Cobra Mark II. You can decide which planets to go to. You can buy things from an agricultural planet and sell them then on an industrial planet and things like that. I'll actually just show you a little bit about the really hard thing about this was the very first thing you had to do in this game is you had to dock at a space station. And it was impossible. And every time you docked and you died, you had to go and reload your game and start again. So it was rather tedious, but this is what the 3D graphics were like back when I started doing 3D graphics. Here we go. So that's Elite, right? The very first 3D games. So we're going to jump forward a few years. Let's jump forward to 1998. We'll have a look at a game called Federation of Free Traders. So this was a similar game. PCs are becoming a little bit faster, and the first game to ever have this fully rendered 3D environment was a game called Wolfenstein. Does anybody play it? Have you played the original Wolfenstein? Let's check and see what year Wolfenstein came out. Wolfenstein was out in 1992. So this is Wolf 3D. So this was the next evolution in 3D graphics. So basically, I suppose you can see, this is what we call a corridor shooter. You know, corridors that you walk down and you shoot Nazis and things. So that was the state of 3D graphics back in. That was the state of 3D graphics back in 1990, I think, was Wolfenstein. 1992. Right, I'm going to skip some of these videos, but I'll show you the next big one. The next big one was a game called Doom. Anyone played Doom? We played the original. This is the original Doom, which I think was 1993. We can check again, right? So the big advance here is that the corridors are no longer square. You know, you can go upstairs and downstairs. Interestingly, this game, so I'm going to play PC games. You play PC games, you typically use keyboard and mouse. This was a PC game that you controlled entirely. Alright, so I'm going to jump forward a few years. The next game, let's pick Quake, right? Because Quake was the first game to use hardware accelerated 3D. Okay, yeah, okay, well let's look at the Nintendo 64 thing then, which was... Did I even down? I don't see the video here. Maybe I forgot to download it. Where's Quake? I see if you're missing Quake. Well, that's okay. Okay, we'll have to do it forward. Alright, then GoldenEye, and then the very first Half-Life game in 1998. And Unreal 2 was the last sort of 3D graphics heavy 3D game in 2003. And Unreal 2 was, why I say it was the last was because in 2004 there was a huge step forward with the game Half-Life 2. Has anyone played this game? So if you played this game, why was this such a great leap forward? Can anyone tell me? Yeah? Physics, that's why. So up until this point, all games basically were kind of static worlds that you moved around. And Half-Life 2 was the first game to make use of the physics engine. So, yeah, where's Half-Life 2 here? Look, Half-Life 2, okay. So I'll just show you a little bit of this one. So this game was in 2004. And you can see what's interesting about this game is that the world is trying to lie. We've got buoyancy in the water here. You can hit things and they respond in a physical or physically simulated way. Things go on fire. Things break up when you hit them. Scroll forward a little bit. Yeah, so you can blow things over and happen. There's exploding barrels. So that's the game Half-Life 2, right? Alright, so interestingly, Half-Life 2, there's been a few small advances in 3D graphics, but Half-Life 2 was kind of around about the era of the Xbox 360 and the PlayStation, so they came out around about that time. And that's kind of, because we haven't had any new consoles for a while, you know, things haven't moved forward hugely. There's been some small advances in graphics. For example, there was a game called Crysis. How many people played that? We'll take a look at Crysis, right? Because Crysis, one of the big advances in Crysis was that it was a huge open world game. Where's my Crysis? And the other thing is, you can see that from a graphical perspective, this was, you So this is what Crisis is called. You can see that you have soft shadows, so very realistic lighting from the sun, and everything's shaded. You have these massive open worlds. So you're actually, you can hang glide around this entire island. In the second game in this series, you actually drop from an airplane and you parachute into the island, and you see the island get progressively more detailed as you drop in. That's almost like real life, isn't it?
Blowing up the pumps of that gas station would cause a nice distraction.
There are very few games, for those of you that are not violent here, there are very few games that don't involve shooting things. That's a problem. We need to have more games that don't have violence. Yeah, that's true. Just Minecraft, right? And okay, everybody. So, like, that's as far as we've come, really, in terms of, you know, the technology. It hasn't really come any further than that. There's been a few other really big, important games like Assassin's Creed 2. What was the big advance in Assassin's Creed 2? Yeah. Right, that's Portal. Is that a different game? Yeah. That's right, yeah. What's that? Free running, yeah. So the big advance forward with Assassin's Creed 2 is this huge open world populated with kind of things that appear to be alive in them. So if you ever played Assassin's Creed 2, it's set in 16th century Florence. And if you ever go to Florence now, you'll see that they've done a great job of actually rendering the entire city. The Duomo is there. Everything that's still there is there now. Okay, so I want to actually take a couple of, let's see what we got here. Yeah. So how many people here are on Steam? Have Steam. Right, when you take out your phones, I want you to set a reminder. Does everybody know what Steam is? Yeah. So Steam is a way of getting games and playing games on the PC, right? So a lot of our students here in the DIT are very interested in making games, and that's basically what we, you know, that's what I'm focused on teaching people here. And one of the games that one of our student teams has developed is this game here. It's called Coup. Now it's not a 3D game, but it uses the Unity game engine. And if you're on Steam, you can take a couple of minutes to go and vote for their game on Steam Greenlight. Okay, so if you have a mobile phone, set a reminder for yourself. I'll just show you a little bit of it. Coup we have. All right, so this you'll be able to get on the iPad very soon, right? So it's basically the story of Cuchulainn. It's kind of set in the future. And all the art assets in this game are all hand-drawn. Anyone from a Gael school here? Do you all love Irish? This is a great way to learn Irish because this game will be released in Irish and in English. It'll be released in the next few weeks on the iPad, on PC, probably before Christmas. It's a great game. It's really a lot of fun, a lot of interesting puzzles. So this was developed by a company called Bidsmith Games, and they are all graduates of the School of Computing. And this is their first product. And we have other games companies which were set up by students. All right. So anyway, hopefully you've got a good sense from that little short presentation about, you know, where computer games are going. Right. The next part of this talk is all about how do computer games work and how are they actually made. All right. So first thing is that there's really two aspects to this, okay? The first thing is actually all of the representation of the 3D scene. So the 3D scene is actually stored in full 3D on the graphics card. And then there's a process which the game engine does, which is to take that entire 3D scene and render it to a 2D image, basically your screen, all right? And how that is done is by means of a certain amount of mathematics, all right? The other thing is the actual game engine is programmed using a language. We usually call it a language called C++. So C++ is a programming language that basically allows you to represent software objects. So the entire scene that you see and the entire engine that you see is represented in software. The actual maths, how many people are doing, what year are you guys in? Second year, okay, so you haven't even thought about honours maths or past maths or anything like that yet. The interesting thing about the maths aspect of games is that it's a certain process that you have to go through to learn, but it's not very hard. I, for example, did not do honours maths for the Leaving Cert. I did ordinary level maths. Because I never thought I was all that good at maths until I started programming games. And then all of a sudden I could see a reason for maths. But up until then I never saw what's the point of all of this. You know, but the interesting thing is, have you all done trigonometry? No. Do you know what sine and cosine and tangent are? No. I don't believe you. We did that in primary school. Do you know how to calculate the length of a line? Yeah. Do you know about the theorem of Pythagoras? Yeah. Okay. What about the unit circle? Yeah. Okay, so once you get a little bit further on in your careers as your academic life, you'll learn about a lot of these very simple little mathematical concepts which are fundamental to the programming of a 3D game. Now it does get a little bit more complicated, but not much more complicated, in that you add a thing called linear algebra, which is vectors, and you add another thing which is called a matrix. A matrix is a very simple kind of idea. It's a way of multiplying things, which is basically what a graphics card and what a console does in order to render that 3D scene. So now we get to the maths. Okay, I'm going to do an actual coding demo in a minute, right? But I just want to explain some of the mathematical concepts first. Are you familiar with the concept of coordinate geometry? Yes. No. Yes. Yes. Okay, so coordinate geometry means that you can represent the position of anything in 2 dimensions using 2 numbers, the x number and the y number. Isn't that right? Yes. So the x number tells you how far you are away from the origin, yeah, from the y-axis, and the y number tells you how far you are up. Isn't that right? Yeah. So in order to represent a 3D scene, like the ones that we looked at, you need to add another dimension, the 3rd dimension, and the 3rd dimension is called the z-axis. All right, so the y-axis goes up, the x-axis goes this way, and the z-axis goes this way here. If you want to think of it about a screen, it goes into the screen and away from the screen, so that's the z-axis. Is that alright? So you can represent any point in 3 dimensions by representing them as 3 numbers, the x, y, and z numbers. Alright, so then you program a scene onto the graphics card. And the scene is programmed, so we've got 3 examples of different representations of a character from the computer game. So over there on the right of the screen, on your right of the screen, you see it represented as triangles. Alright, so when we talk about the x, y, and z now, we're talking about the corners of the triangle. And the corners of the triangle in graphics terms, does anybody know what it's called? They're called the vertices of a triangle. So this is made by an artist. Right? An artist uses a 3D program to generate the 3D representation of the character as a set of triangles. And each one of those triangles is represented by an x, y, and z coordinate. The second image that you see there, the one in the middle, the triangles are basically flat, so a texture or a flat face is drawn onto each one, and they're basically smooth, right? And in the 3rd image over there, what has happened is a 2D bitmap, a 2D image is overlaid onto each one of the triangles to make it look like it's a 3D, you know, and that last process is called texturing. So you take the triangles, you shade them, you know, draw a face onto them, and basically painting onto the face, and that's called texturing. And I mentioned the Matrix, didn't I? Has everyone seen the movie? Yeah. Okay, so this bit at the top has got nothing to do with the movie. This is what a matrix looks like. A matrix is just a grid of numbers. So it's got rows and columns. And this magical matrix is at the heart of every 3D games engine. Because what happens is, you represent the scene as all of those 3D vertices, and then there are 3 matrix multiplication operations. Each of the 3D things is multiplied by a different matrix in order to take that 3D image and render it onto a 2D display. And that process is called projections, projection onto a 2D display. And the matrix can do either of three things. It can translate. What's a translation? In graphics terms, a translation just means a movement. So you can move things. You can rotate things. Or you can scale things, make them bigger or smaller. So there's three operations that the graphics card does and the engine does. A person starts out and they make all of the model in what's called the local space. So you use something like 3D Studio Max to create the model. And then the first thing that the 3D game engine does is it positions everything relative to everything else in the scene. And that's a matrix multiplication operation. The second thing that happens is the camera is put into the scene. Alright, and that's called a view space transformation. And then the third thing that happens is the projection. So the projection is interesting because here's the thing that we know as human beings. We know that when something is small, it means it's far away, doesn't it? Yeah. So the matrix multiplies everything so that far away things become small and near things become big. So now, let's write a program to show you how this particular aspect of a 3D game is actually constructed. So, here we go. This is an environment called Visual Studio, alright? And in this environment here, I have a 3D model of a Dalek, and I am now going to write a little program to load and draw that Dalek, right? So I kind of have it here. We're going to set up those three matrices just so you can see, alright? So I just have a small bit of code to do here. So I'm going to zoom in so you can see. This, by the way, is what programmers do. And I wanted to include this as part of the talk, you know, because I don't want it to be all just showing you nice videos. This is actually the process of writing a game. This is how it happens. So, the first thing we have to do is make the world's transform matrix. Alright, so we go matrix world equals matrix dot create rotation y. So I'm going to do a rotation on y, create rotation y. I'm going to use the variable spin because I want my little Dalek to spin around. And then I also have to include the translation. So, and what you can see here is that writing a computer program is somewhat like a combination of maths and English. So we will also create a translation. And the translation is going to be using the variable pause. Alright, so that's my world transform matrix. The second matrix I have to make is the view transform. So that's going to be matrix dot create look at, look at. And the parameters that I pass into this are the position, the position plus the look vector, look. And then the third parameter is the look vector, C look. So that's the second matrix. Now the third matrix you have to create is called the projection matrix. Now don't worry if you don't understand all of this stuff. I just want to give you a flavour of what programming is about. Create perspective or field of view. And in this, what you specify is you specify the field of view that you want. Math helper dot pi over 4. What's pi over 4? What's that in degrees? Do you know about degrees and radians? Alright, no problem. So basically that's 45 degrees. And then you specify the aspect ratio of the screen. 0f. And the third parameter, what are called the near and the far clip planes. Alright. Create perspective from field of view. And then this is the bit of code which I'm not going to write this because it will take me forever. So I'm just going to uncomment this bit of code. And then you go projection. And then hopefully, if all goes well, don't be too scared now. We should see a Dalek on the screen. Does everybody know what a Dalek is? Oh, hang on. I need to comment something out here. This is what happens when you do a live demo. I commented in too much of the code here. So what I actually need to do is load Dalek. exactly. And I want to do spin plus equals to 0.01F. Oh my god, look at that. Don't be too scared. Don't be too scared. It's not real. Anyway, these are what programmers do, right? So, I'm kind of coming to the end of my bit. I'm going to ask Thomas to come up, right? If you want more information about how 3D games work, you've got to come and study with us. DT228, DT211 are the course codes for our 2-degree programs. You can follow us on Facebook or on Twitter. You can see all the code, you know, the programs I've developed, and lots of YouTube video tutorials and things on my YouTube channel, right? So, anyway, there we go. So we're going to, you just get set up there for a second. So, why I've asked Thomas to do this is because, well, the thing I do is teaching people how to make game engines. What Thomas is going to demonstrate here is using an actual game engine. It's the same one that's used to make Dishonored, and this is called the Unreal Engine. All right. Interestingly, you can download this engine for free, and you can start making your own games in it. All right. So, are you ready to go, Thomas? All right. So, why don't you fire it up there? All right. Well, basically, here I'll give you some sound, right? Alright, so before Thomas starts, give him a big rousing
Anyway, basically, as Brian said, this engine can be downloaded for free. It's a great engine. I've been using it for years, but only after, during the summer, started to code for it. I've been doing computer science. But anyway, I'm going to fire up the game. I'm basically just going to take you through what's going on, that's what's happening, and I'm going to show you how it interacts with the editor, which is what you would use. And then I'm going to show you a bit of code for an algorithm that makes the enemy basically come to the player, which you'll see in a second anyway. Maybe afterwards. Okay, so basically, it's clear as hell to me, but okay, so the topic you can make now, I got an XP system and a leveling system coded in. Bottom I got crystals and health. The way this works is it's all down to the player's code and all that stuff that goes with him. So anyway, I'll go forward now. So all this controlling and stuff, the mouse moving left and right and all that is all coded in. The moving around and how it's respective to the camera's position to the player. So for example, if I'm facing this way, you know, to my right, and I press A, which should, you know, you think in terms of, you know, going straight up into my left side, takes me left just to the orientation of the player. Anyway, so this, for example, right here is what Brian said, or maybe didn't say, is a class in programming. And a class is basically, it holds a bunch of properties to an object. So this crystal cage here is protecting this crystal is a class, and it has all its properties, such as it takes damage and it has a damage or how much health it has, and it fire effects that follow when it plays or when it gets destroyed, and it can take damage from what I use. So I'll fire at it, and you'll see it blows up. So it's very simple to all of you, especially when you play games, you blow up stuff all the time, but you don't really realize how much code goes behind it. So the same way as like my player is currently holding a weapon, and that weapon allows him to collect these crystals. Otherwise, if I didn't have this player, I couldn't touch those crystals. And when I touch the crystals, it passes through
Feeling much better now.
to the bottom. So it all works together, all comes together. What you don't see, as I said, is in the background there are like 3 or 4 different classes working together. Probably about 200 or 300 lines of code together to just do this simple thing that you probably take for granted in all your games that you play. So, oh yeah, and you also saw that XP was getting at the top, and down level 1, or it was already level 1. So I'm going to go forward, and in a second you'll see an enemy spawn. I kill him, he's getting more XP, and then it's level up. Yeah, great thing. And also when I get to these levels right here, you're going to see certain skills come into effect that I've got only activated when you access these skill levels. which you're going to have to go progress. So I'm just going to go forward until we get to the next level, and I'll see it all going together.
Just what I needed.
Yeah, he's just a pretty charismatic little guy.
Yeah, all right.
So this here is just a simple kind of show and hide something that's attached to the player. So all the time it's actually there, you don't see it, it's just hidden from view. Anyway, so here, we're level 3 now. Yeah, so, that's some more XP. There's another crystal. Let's say, for example, I didn't know where the crystal was, and I run around here and I'm like, oh, where's the crystal? So I have the ability now. I can spawn this little star, it goes towards wherever the next point of interest is, whereas in the editor I've got another separate class I have that I've placed above these points of interest. So it goes there to show me where to go, and every time I recall it, it's going to spawn at me and take me wherever it is, and I'll show you the vector math afterwards of how this all works. It's the same as the enemy finding my location and coming to me. It's the same as going to that. So,
Just what I needed.
level up again, got another skill, which I use in the So yeah, all this as well, like I said, it's a free download, and everything you see here actually came with the editor. The only difference is I made badly the staff and the hat and stuff, but all the textures, all the models, and all that stuff came with the editor. You can download it and get straight away using these assets. All the extra gameplay is done through visual scripting, which is a kind of easier way for
Better now.
level designers who make these things to program when they don't actually know how to program. It's the coder's nice way of being nice to them. So anyway, so I need to go back that way, so I'm going to see it, I'm like, oh, it's way over there. So, actually, my next ability. And I didn't deactivate that. The way that worked was basically, when I call, in programming, calling is calling a function, and a function is something to be proceeded to happen when it works. So when I called my function right there, what it did was it took my moment in time playing the game, and it put that into a value, basically, variable. And then I told it that basically, as the time goes on in the game, if 3 seconds pass, then to turn off, or to follow the next part of the code, which is to turn off the ability. So I go back to getting my normal speed, rather than it being changed. And it's the same way it works with the next ability as well, which I've just gained with, just in a second. The next one is basically, if you're being overwhelmed, which you're hard to do, it's not that hard. But it's like this, just, I can't believe while that's happening. But all those little crystal things, yeah, so just that.
All right.
I'll probably stop out now after this, because that's pretty much everything in the game. Coded, the next level is pretty much extra gameplay if you played the game. But I'll go in now and I'll show you how the code interacts with the editor. For this, I'll just use the enemy was fine. Okay, so the enemy was the dude who was spawning there, and there's all the code that makes him work. So, for example, you know, that's him. This placeable card basically says in the editor you can grasp this as an object and put it into the game and drag and drop it, place it into your world you created. All those top things are just variables. Anyway, but yeah, here. So if I show categories, you can see here is my stuff that I created separately outside of the editor in my game. And when I've coded it, quite simply, as you can see, here's the enemy. Down here you can see he's the enemy there. And if I was to grab this, I can drag and drop that. Screen resolution, but yeah, you can drag and drop it into the world, and it has all the properties that it has to do what's going on. And that's how the editor interacts. And I won't go through a big tutorial on how to use the editor, because you can go and learn that yourself. It's a very powerful and brilliant engine to use. But if I was just to show you, for example, the code that I said was the enemy finding me, which is this. I'll take it out first, and I'll show you what happens when I take it out. It's back a few times. This just recompiles the scripts that you have written. It's basically telling you that everything's fine, everything's okay, and whatever I've written makes sense of sometimes this compiles and there is problems, but not necessarily you yourself solving things separately. But yeah, so a lot of just a specific level at the moment. Sorry, the big Unreal thing every time it comes up. So now when the enemies spawn, they're just going to stay there. There's no AI or thing telling them to do anything. They're just sitting there. They still take the other properties such as damage or whatever, but they don't mean anything to me as a player. So you know, I got to write code that makes them, well, not exactly interesting, but work. So I'll take back out this code, or put it back in. I'll just explain line by line what's going on. It's a very simple, powerful algorithm in the game. So function tick delta time, which doesn't like viewers view. Basically what that means is, you know, games run at 30 frames per second or 60 frames per second. Every frame that is happening in the game is calling this function and running everything through it once. So when you do a frame, or if you run a game 100 frames per second, every 0.01 seconds, this is running in the background. So basically what this is doing now is it makes these two local variables of the other classes. Okay, so this is all sounding very confusing. And it's making a vector, which is Ryan was talking about. You know, it's how the games know the x and y and z axis and stuff. And so I have a statement, if statement. Basically, try and understand if statements mean if this, then this. So if I was saying, you know, if I twist the ignition in a car, then turn on the car. Or, you know, if it doesn't work, so if I haven't twisted turn on the ignition, then it's not going to turn on the car. So what it's doing is saying if the enemy's enemy is equal to none, so he doesn't have an enemy. When he spawns, there's no one he has a target of. It runs through for each local player controller. It runs through my class, which is the AG player controller class, which is used for the player. And it says if I exist, the exclamation mark at 0 means not equals to none. So it says if I exist as a player, and the enemy of this enemy becomes me. The next time it runs through, that happens in pretty much the 0.01 second, the one frame that you do this. Once that happens, it goes to the next because it's satisfied. Next time you come through the function, it doesn't need to say if enemies equal to none because it doesn't. So it says else if, which basically runs that if you've done that, it comes to the next. Basically just saying, the first one's done, let's do this instead. Now, v-size location by enemy location. Okay, v-size is basically vector size distance between the first element A and the second element B. So the vector between the location of that actor, which is the enemy, minus the location of the enemy's location, which is me. It says that if it's less than the follow distance, which I've designated somewhere else as something like 1,000 or 1,500, and there's some other code there basically satisfies that everything is going fine, then it's to run this code. And it basically says if vector size, once again, inside that is less than a certain amount, so say 5, then it should attack me. So the PC bump self-collision stuff, basically, I've got bump as a damage variable. That's why every time it hits me, it does 15 damage. But if it's larger than that, so it is still at the 1,500 distance, it does this algorithm, which makes it constantly come towards where I am. So it creates a variable basically called the new location based on the current location of the object. If the object spawns here, its now location is that area. Then in the next part of the line of code, it says to increment. Plus and equals means increment, which is basically add 1. So if I told it to increment by 1 and told it to run 10 times, 0 would eventually get to 10. So by incrementing the enemy location, which is me, minus its location, and multiplying it by delta time, which is basically the frame everything's happening, then it's going to move towards me per 0.01 second and go calculation to move its location towards me, because I say set location is the new location which I've just designated. So then it just comes to me and it runs this algorithm every time this is called until it gets close enough to the attack distance where it's the curtain. Yeah, so anyway, this has been basically me showing you all of the stuff, and I do encourage you to download the Unreal Engine. It's a really awesome engine. It's a free downloader and you can play it, and it's the top most used engine in the world in any shape, way, or form. It's used in all the top blockbuster games, apart from any that are really first party. But yeah, so yeah.
Cool. Thanks. Our open day takes place on the 31st of November and on the 1st of December. And if you want to come and meet Thomas and some of our other students components.